Large linear classification when data cannot fit in memory by Xiangfu Yu, Zhuo Ruixie, Kaiwei Zhang, and Zhiren Lin from National Taiwan University. In recent years, the size of the data increased steadily. For example, in 2004, it takes around 40 MB memory to train the largest data in a data mining challenge KDD Cup, and it takes 1.6 GB in KDD Cup 2009. However, in KDD Cup 2010, the size became about 10 GB. Moreover, there are more and more applications such as spam filtering and web mining that applies large-scale classification. Several internet companies also report the needs to deal with large-scale data with billions of samples. Among various classification techniques, linear classification is a popular method to deal with large-scale data. If data can store in memory, efficient methods are already well developed. However, if data is larger than memory capacity, the disk swapping causes lengthy training time. For example, in the figure, the blue line shows the training time along data size of a linear classification package liblinear. The dotted green line shows the memory capacity of the machine. When data is larger than memory, the training time increases rapidly. In this work, our goal is to construct a large linear classifier to handle data larger than memory on a single machine. The training time can be modeled to two parts: the time to train data stored in memory, and the time to access data from disk. The design of the existing methods usually focus on the first part. However, now we need to pay attention to the second part, as the loading time may dominate the training time. For example, in online learning, a learner considers only one sample at a time. Therefore, they can only apply a simple update rule on the sample. This setting may require many iterations to converge. Therefore, when an online learner loads data from disk at each step, disk I/O bound become the bottleneck of the training process. There are three conditions of designing a classifier for training data larger than memory. First, each optimization step can only read continuous chunk of training data from disk. Second, the optimization procedure converges toward the optimum. Third, to save I/O, the number of optimization steps should not be too large. Also, the method needs to be simple so that it can support some important functionality, such as multi-class classification and parameter selections. We consider a block minimization framework. We split data into several blocks, such that each block can fit in memory. Then, we store each block in a separate compressed file. The algorithm loops until the model converges. At each time, it loads one data block into memory and solves a subproblem on the samples in the blocks to update the model. The subproblem can be solved by existing packages such as liblinear. We apply the proposed method to train a linear SVM on a 20 GB dataset in a machine with only 1 GB memory. The figure shows the difference to the best accuracy performance along the training time. The lower is better. Compared to the original liblinear package, which suffers from serious disk swapping, the proposed method solves the memory problem for training linear classifiers. We also compare the method with the VW package, which is one of the fastest online learning software. We show our method is more efficient as it fully utilizes the data in memory by considering a data block at a time. In summary, we propose block minimization method to effectively handle data 20 times larger than memory. We released the package at our website. You can now train in pretty large data on a machine with small memory, like at a laptop.